Hello, everyone. I hope everyone is doing well. And we're going to continue talking about reactions. And cool thing is that all chemical reactions actually are one or a combination of four simple reactions. Combination. Screw that up. Right. Just a couple of reminders, quick reminders. That G or GH would be elements. Elements, we have uppercase or uppercase, lowercase. However, GH or GHX would be compounds. I mean, it's still a compound. I'm going to throw one more compound in here. Or GHX. These are all compounds. And we can tell that they are compounds because they consist of two or more elements in them, okay? So now for our simple reactions. First one is called the synthesis reaction. And it's where you have two or more smaller elements. I'm sorry, smaller substances. And they're going to form one substance, one more complex substance. Okay, so that could be G plus H going to GH, right? Or it could also be GH plus X going to GHX. The point is that it always forms just one product. And then decomposition is the opposite of synthesis. So a decomposition reaction is where you have one complex substance that turns into two or more simple substances. So we can have GH turning into G plus H, right? Okay, and then the next two, a little bit more complicated, but not super complicated. We have, the next one's called a single replacement reaction. And it's exactly what it sounds like, that one thing's replacing. So you have a compound and an element. And they react to produce a new compound and element. And I'm not meaning that we're creating a brand new element. It's an element that wasn't by itself in the reactants. Let's take a look at the reaction. So GH plus X yields GX plus, I'm sorry, that's GX plus H. So we can see that there was a single flip-flop, a single replacement. These two replaced each other, right? So this is what I mean, that we didn't have element H by itself in the reactants. We have it in the products, right? So here's our new compound, GX. GX, the substance GX was not in the reactants. We have G with X, but not GX. And the substance H was not in the reactants. We had GH. Those are different, okay? And then one more, just like single replacement, but it's called a double replacement reaction. And this is where we have two compounds instead of one. React to form two new compounds. So let's take a look at the general formula for that. And so we have gx plus hy, and that's going to become gy plus xh. So we can see that these are, we had the y and the h were flipping out, and the x and the g, right? We had kind of two different replacements there, right? I guess the x and the g stayed constant, but we had compound switching out, right? So that's what's called a double replacement reaction. Single replacement reaction can always be identified because it's always a compound and an element turning into a compound and an element, whereas double replacement is always two compounds turning into new compounds. And like I said, the cool thing is that we can use these reactions to predict products. And let's take a look at some. So first one, let's take a look and let's have what we're going to do. We're going to do a single replacement. So let's do, I don't know, let's do Na2SO4 plus Li. If that's a single replacement, we know that the La and the Na are switching out. So we would have Li to SO4 plus Na. So we notice, and the first thing you should notice is that this is an unbalanced reaction. So I'm going to balance it. And I see that there are two Li's on the right, one on the left. And I see two NAs on the left, one on the right, and it's balanced. So notice how predicting products is two steps. And do not skip steps. The first step that I did, first, we used the crisscross method to find the chemical formulas of the products. So that was the first step. Then the second step is that we balance the equation. So it's okay if after your first step, your equation isn't balanced yet. Let's do a couple more practice. One more practice I think should do it. And this is a super tricky one. Let's have Na2 CO3 plus, I don't know, FeCl2. Now, our two products we have, because it's a double replacement, we have the CO3 flipping with the Cl. Now, a lot of you are going to want to just move that and move that, but that's because you're not following the crisscross method. You have to follow the crisscross method. Na. Na we know has a charge of +1. Cl has a charge of -1. Crisscross to make NaCl. Most of you are probably right now going, Mr. Schreiber, but there are 2's there. I know there are 2's there. That is not the step we're on. We're on step 1, which is using the crisscross method. NaCl. Let's crisscross the next 2. Fe here is going to have a charge of +2. We know because there are 2 Cl's. CO3, we look up, has a charge of -2. Fe, oh, sorry, Fe +2, CO3 -2, FeCO3. There we go. Now that we've done that, now we go back and balance. That's why balancing is the second step. We throw a 2 there, and it's all balanced out. Please don't skip steps. Please don't. Remember, this is how we predict products. The crisscross method tells us how to predict the correct chemical formula. It doesn't tell us how much of the chemical formula. That's why step 2 is balancing, okay? I hope everyone enjoyed this little lesson, and I hope you have a good night. Bye.